طيب بسم الله والحمد لله والصلاة والسلام على رسول الله وعلى آله وصحبه وله. Any questions before we proceed? No questions?
No, sir.
Okay. So basically what we have done is we have taken few examples on how to compute the probability using the definition probability of an event E equal the cardinality of E over the cardinality of S. So let's continue with a few more examples, and then we will move on to the next section. Okay. Right. So suppose that 100 people enter a contest, and that different winners are selected at random for first, second, and third prizes. What is the probability that Kumar, Janice, and Pedro each win a prize if each has entered the contest? If each has entered the contest. Right. So the first question that we need to ask is the sample space. What is my sample space, and what's the cardinality of the sample space? 100 factorial.
B 100 103
P 103. ليش P 103?
لأن
Because I'm differentiating between the first prize winner, the second prize winner, and the third prize winner. So ordering is important, صح? Ordering is important. So therefore, oops. ناخذ الأطول شوي. Okay. So basically S consists of oops شو اللي سويته هذا؟ S consists of all ordered triplets. صح؟ أو all ordered triplets of names, right? Of names. So in this case, the order, the cardinality of S is P 103, which is إيش? 100 times 99 times 98. طيب. What's the probability that Kumar, Janice, and Pedro each win a prize if each has entered the contest? So now, what is the cardinality of E?
3 factorial.
3 factorial. Why 3 factorial, not 1?
Because there are 3 ways you can get 3 factorial ways you can get.
There are 3 factorial ways that each one of them wins a prize. I didn't say Kumar wins the first prize, Janice wins the second prize, and Pedro wins the third prize. I said each one of them wins a prize. Huh? So in that case, the size of E, or the order of E, is basically 3 factorial, and therefore the probability of E is equal to 3 factorial divided by 100 times 99 times 90 times 98. Okay? ال 3 factorial هي 6.
لا 3 choose 3 most 3 choose
لا.
B
P33. P33 هي P33. Okay? طيب. Can anybody give me a solution where the sample space consists of 3 people without ordering?
إذا 3 يفوزون نفس النقطة.
No.
فايز ما
Sample space,
Yes.
3 people entered the contest.
That 3 people enter the contest, صح? Because what is required? What is the event that is required?
Entering.
إنه 3 those three win a prize, صح? So does it matter الordering تبع البرايز? So if the ordering of the prize does not matter, I can also consider my sample space to be all triplets of people without order, صح ولا لا? All different triplets of people. So I can specify S. So this is solution 2. Solution number 2. This is solution number 1. Okay. In fact, one of your colleagues, pointed this out in section 2. Okay. So in solution number 2, what we're going to say is we're going to say S consists of all triplets of people. So here ordering is ايش? Ordering is not important. So in that case, what is the size of S? 100 choose 3 صح؟ طيب what is the size of E?
1, 3, choose 1. 1 or
1.
oh,
1 triplet. صح? So therefore, what is the probability of E? 1 over 100 choose 3. Let's see, is this exactly the same as the one on the left? So this is what? 1 over 100 factorial divided by 96 factorial, 97 factorial, صح? Times 3 factorial. طيب, what is this? Isn't this 3 factorial نحطها فوق وتحت ايش رح يضل عندي؟ 100, 99, 98. Exactly the same. Exactly the same. طيب. This is interesting. Yes.
I have a question to this one.
Yes.
So winning third is the same as winning second.
Here, winning
Same
first
answer.
or second, it's just winning.
So it's
Winning one of the three prizes. That's the event that we're. طيب. So now, in some game shows, in the last step, the winner will be given the opportunity or the chance to win a large prize. So the idea is the following. You will have 3 doors. Here, according to this, you have 2 goats, 1 goat behind each door, and the 3rd door has actually a car. Now, for me personally, if I get a goat, well, this is good. But for them, it's loss. Well, you can also assume that 2 doors are empty, nothing is behind them, and the 3rd door has a car. Okay. What will happen is the following. You are asked to select one of the 3 doors to open. Okay? So either door 1 or door 2 or door 3, you will choose one of the doors. You say, I would like to open this door and get whatever behind it. Okay? Right. So after choosing the door, after you choose one of the doors, and before the result is shown to you, the game host will do the following. Will open one of the other 2 doors and guess which door he will open. The losing one. Definitely he will not open the door that has the car. Definitely he will not open the door that has the car. So the show host opens one of the other 2 doors, which is a losing door. Now at that point in time, the show host will ask you as a contestant, would you like to stick to your original door that you have chosen, or would you like to change? Which strategy should the contestant follow? Which strategy should the contestant follow? Okay? Fine. In order to answer this question, let's first answer a couple of questions and then I'll take your ideas. So, what is the probability that you choose the right door? 1 over 3. Isn't that clear? From the beginning, يعني the probability of choosing the right door for you is basically 1 over 3. طيب, what is the probability of choosing the wrong door? 2 over 3. The probability of choosing the wrong door, 2 over 3. طيب. So now, who would like to tell us, what do you think? After a door has been opened, should you change your answer? Should you change the door, or should you stick to the door that you have chosen?
You stick to the door.
Why?
Probability has increased. 2 over 3. To the door.
The probability of that door has increased to 2 over 3.
Yes.
So now, and what happened to the probability of your door?
Increased.
No, the probability of my door increased, not the other.
Probability of your door increased? So this means you do not change.
Yes, I said don't check.
Oh, you don't change?
Yes.
Ah, okay. Fine. You change, ليش؟
لما نختار هذا فاحتمالية الباب اللي نختاره تكون أعلى إنه هي تكون السيارة. Isn't it 50-50? It doesn't matter at that point.
When I change that, it's like I choose 2 doors, the other 2 doors. So it's like the other doors is 2 or 3.
In fact, that's the answer. And let me convince you with the answer in the following argument. Okay? That the best strategy is that you should change. Okay? The best strategy is that you should change. Let me convince you. See, we have basically 3 cases. Huh? We either choose the door where the car is behind, or we choose the first wrong door, or we choose the second wrong door. صح? طيب. So now, if let's look at what is the probability of winning if I do not change. What is the probability of winning if I do not change? So, in this case, am I going to win or I'm going to lose if I don't change?
Case 1. Win.
I'm going to win, صح? طيب, what about here?
Lose.
Lose. What about here? Lose. So, what is the probability of not changing? 1 over 3, صح? 1 over 3. طيب. Now, let's assume that I choose a strategy to change. So now, if I change my answer in the first case, did I win or did I lose?
Lose.
I lost.
Yes.
طيب, if I change my answer in the second case,
You win.
I will win because I know one of the doors that is a losing door is already open, and since I'm changing, I'm definitely changing to the right door, صح? So this is a win. What about here?
Yes. Win.
This is a win. قديش صارت?
2.
2/3. 2/3. So it is better to change. It is better to change. Now, if I think you are convinced now, but let's assume that you are not. Okay? Let me now give you convince you really well. Okay? Instead of 3 doors, assume you have 100 doors. And the car is behind one of the doors. Now you choose one of the 100 doors. What's the probability that you have chosen the right door? 1 over 100, صح?
Yes.
Fine. The game host opens 98 doors. Now, will you change or will you not change? Although there is a probability, the door that you have chosen, the car is behind it, صح? But that probability did not change. It is still 1 over 100. Now, what happened to the probability of the other door that is left open after opening 98 doors? It became 99 over 100. It became 99 over 100. That's why, if we look here, the probability of winning without switching is the same as the probability of winning before the show host chooses a losing door, which is 1 over 3, صح? And the probability of winning with a switching is the same as the probability of losing. Is the same as the probability of losing before the show host, chooses a losing door, which is basically the 2/3. Which is basically the 2/3. Okay, يا شباب؟ واضحة المونتي هول problem؟ طيب، very good.
So,
نعم.
الحين لما الواحد يختار ويبغى يغير يكون الباب اللي اختاره مفتوح يعني.
الباب اللي اختاره لا ما بيكون مفتوح، ما بيكون عارف.
طيب كيف يكون أقل احتمالية؟
لأنه صار احتمال إنه الباب إنه the probability that the car is behind one of the quote unquote wrong doors or the other doors, if you open one of them, the other one, it becomes the same as the probability of losing in the beginning, which is 2/3, which is higher than 1/3, which is higher than 1/3. طيب, so let's move on to section 2. Now, as we were mentioning before, if I define the probability of an event to be the cardinality of the event over the cardinality of the sample space, we are assuming that all events are equally likely. Okay? Or we are assuming that all, maybe it's better to say outcomes. All outcomes are equally likely. We are assuming, I think maybe I should change this. That all outcomes are equally likely, but this is not always true. Sometimes some outcomes are more probable than other outcomes, and this is what we will see today, inshallah. Okay? So, in this section, we will study the following concepts: conditional probability, independent events, and random variables. We might not get to any of them today, but let us set the stage and see some examples where some outcomes are more probable than other outcomes. Okay? So let S be the sample space of an experiment with a finite or countable number of outcomes. Do you see now a deviation from the definition that we gave in section 1? In section 1, what did we require S to be? Finite, huh? Now, what are we now we are relaxing this requirement to finite or countable. Countably infinite. Okay? We assign a probability P of S to each outcome S. So each outcome S is assigned a probability PS. Now, this probability PS has to satisfy two conditions. The first condition is that its value, P of S, should always be greater than or equal to 0, less than or equal to 1. The value of the probability of each outcome should always be greater than or equal to 0, less than or equal to 1. What about the second condition? Well, the second condition is that the summation of the probability of all outcomes should be equal to ايش? Should be equal to 1. Should be equal to 1. And by the way, if the number of outcomes is countably infinite, it is possible to have this condition satisfied, صح? Because some infinite summations are convergent, right? So it is possible to have infinite number of outcomes. It is possible to have infinite number of outcomes. طيب. So let us have some definitions. So suppose that S is a set with n elements. The uniform distribution assigns the probability 1 over n to each element of S. This is what we have seen in the previous sections. Huh? So if order S and then E, if it has 3 elements of S, it will be 3 over the cardinality of S. So it's exactly the same, right? Right. Now, the probability of the event E is the sum of the probabilities of the outcomes in E. Now here, we are kind of deviating from the previous section. In the previous section, we already know that each one of them is 1 over n, صح? Now here we don't. That's why we cannot say order E over order S. What do we have to say? Well, we have to say P of E in this case is the summation of P of S, where S is an outcome in E. So we need to check each outcome and examine what is the probability of that outcome. Okay? So let us have 2 more theorems before we look at our first example. طيب. Let E be an event in a sample space S. The probability of the event E complement, the complementary event of E, is given by probability of E complement 1 minus probability of E. Is this the first time we see this? No, we already seen that before. Okay? So this is good. طيب. Look at the other theorem. Let E1, E2, etc. be a sequence of pairwise disjoint events. Now, this basically kind of, points to the fact that it is possible that I have an infinite list of subsets, صح? That I can have an infinite list of subsets. Now, if I choose any 2 sets, let's say EI and EJ, where I is not equal to J, and EI intersection EJ is empty. So none of the outcomes in EI is in EJ, and vice versa. Then what can we say about the probability of the union? Well, it's nothing but the probability, it's the summation of the probabilities of each event, okay? And this is what we will be basically using in the following few questions. So let's start with the first example. So in the first example, it says the following. Suppose that a die is biased or loaded so that 3 appears twice as often as each other number, but that the other 5 outcomes are equally likely. Okay? What is the probability that an odd number appears when we roll this die? What is the probability that an odd number appears when we roll this die? Now, in order to find the probability of an odd number to appear, I need to find the probability of each outcome, صح ولا لا? طيب. So how can I do that? Well, let's try to put it graphically, the relationship between each outcome. So the probability of each outcome can be graphically represented as. Now, what does it say? It says 3 appears twice as often as each other number, and the others are all equally likely. So let's say that if we have, 1, 2 appears once, 3 will appear how many times? 3 will appear twice, صح? And then we will have 4, صح? And then we will have 5 and 6. 5, oops. Five and 6. So now, based on this, what is the probability of outcome 3? 2 over 7, صح? And what is the probability of outcome I if I is one of 1, 2, 4, 5, 6? 1 over 7, right? So now I have found out the probability of each outcome, صح? طيب. Now, what is the event that I want to find its outcome? And it is odd, صح? So this is basically which outcomes? Probability of, what is E? 1, 3, 5, صح? So what is the probability of this event? Well, it's the probability of 1 plus probability of 3, صح? Plus probability of 5. What is this equal to? 1 over 7 plus 2 over 7 plus 1 over 7, which is equal to 4 over 7. Yes?
Is it a 7 faces dice or 6?
No, it is 6,
So it must be.
but it is biased.
Yes,
3 appears twice as each of the other outcomes.
But number 1 will have a chance of 1 over 6, not 1 over 7, because we have 6.
No, it is 1 over 7 because 3 has more chance than 1.
But we don't care about it in chance of 1, because 1 is 1 over 6.
هلا, what does it say? It says that 3 appears twice as often.
Yes. But we have 6 faces, not 7.
We have 6 faces. Yeah, we have 6 faces. We have 6 faces. But if, let's say, you throw the die a multiple of 7 times, big multiple of 7 times. How many times 3 is going to appear as opposed to 1 or 2 or 4 or 5 or 6? It will be twice. So now you have 1, 2, 3 appears twice than each one of the others, and then 4, 5, 6.
Yes.
So what's the probability of a 3? It's 2 over 7. It's not 1 over 6. لا ال1 ولا ال2 ولا ال4 ولا ال5 ولا ال6 is 1 over 6 anymore. They are less because 3 appears twice more than them. So the probability of ال1 وال2 وال4 وال5 وال6 has decreased, and the probability of the 3 has increased. Okay?
Can you say 2 over 6?
You cannot.
كده الجمع حيكون أكبر من واحد.
راح يصير الجمع أكبر من Okay?
تمام.
طيب. Okay. Okay. Now, this is a question in your textbook. Okay? Go and look at the solution at the end of the book. In my opinion, I don't agree with that solution. I think it's not correct. Now, I used to give both solutions, but it seems that this time I'm just going to give what I believe is the right solution. However, that doesn't mean that you don't look at, the end of the chapter and you try to reason about it. If you get convinced, please also convince me. Okay? But let me follow in this question what we followed, what we did in the previous one. By the way, this one is actually an example in the textbook. Okay? It is a solved example in the textbook. So let's basically look at this question and see whether we can do it in exactly the same way we did the previous example. Find the probability of each outcome when a biased die is rolled if rolling a 2 or rolling a 4 is 3 times as likely as rolling each of the other 4 numbers on the die, and it is equally likely to roll a 2 or a 4. And it is equally likely to roll a 2 or a 4. Right. Now, let me ask you the following question. Do you think what is meant by rolling a 2 or rolling a 4 is 3 times as likely as rolling each of the other 4 numbers? Is it that probability of 2 is 3 times 1, 3 times 3, 3 times 5, 3 times 6, and probability of 4 is 3 times 1, 3 times 3, 3 times 5, 3 times 6? Or it's rolling a 2 or rolling a 4 as one event is 3 times rolling, 3, rolling 1, rolling 5, rolling 6. The first interpretation or the second interpretation? Huh?
The second one.
The second.
So it will be 3.
Why not the first one?
Or but
Because it means each of the 4 numbers before. So each one of them will be 1 out of whatever, 1 out of the total. This will be 3 out of the total. It will be 3 times
But why the event includes a 2 or a 4, not a 2 alone or a 4 alone? What hints?
It gives you the option. It may be 2, it may be 4.
No. Yes.
can we say it's 2 or 4, but not both, because it's or here inclusive because it's not exclusive.
No, we already know that.
It cannot be equally likely if it's both of them.
Aywa. See, do we have to have this condition if what was meant was إنه 2 is 3 times each one of the others and 4 is 3 times each of the others? Do we need to say and it is equally likely to roll a 2 or a 4? It's not. It would not be needed because it's already 2 is 3 times 1 or 3 times 3 or 3 times 5 or 3 times 6 and likewise 4. Why would you say that it is equally likely to roll a 2 or a 4? So basically what is meant here is 2 or 4.
So now the probability is 1.5.
So now if we say the probability of what did we say in the previous one? Of each outcome can be graphically represented as. So I have 1. If 1 appears once, 2 or 4 appears how many times? 3 times, صح? 2 or 4. 2 or 4. And then I have 3, 5, 6.
How does this make sense?
Huh?
How does this make sense? If it's a 2 or 4?
It's a 2 because that's what it says. If rolling a 2 or rolling a 4. So it's the whole event.
Why isn't it 2, 2, 2, 4, 4, 4?
It's not, because here it says it's equally likely to roll a 2 or a 4. So this means that the question means that the event consists of rolling a 2 or rolling a 4. Both. Yes.
لو كانوا 3 3 4 و3 2 برضه يقدر تصير 3 من 10.
عيد مرة ثانية.
إذا احنا حطينا 3 twos و 3 fours راح تكون نفس الشيء برضه equal because 3 over 10 3 over 10.
Well, let's continue this one and then you'll tell me whether it is the same or not. Okay? طيب. So now, if I do that, assume that probability of 3, our probability, let's say, of I is equal to x, where I is in 1, 3, 5, 6. Probability of I is equal to x, where I is equal to 1, 3, 5, 6. Now, what is the probability of the whole sample space? It should be equal to ايش? To 1, صح? يلا, let's see. So 1 is equal to what? Probability of 1, which is x, plus. Now, 2 will 4 ايش عندي? Probability of 2 or 4, صح? So I have the two outcomes. Now, if this is x, probability of 2 will 4 will be what? Probability of 2 or 4 is, we can do it this way, معلش. Probability of a 2 or 4 is equal to 3x, صح? So now 1 is equal to x plus 3x plus probability of 3 plus probability of 5 صح؟ plus probability of 6. مظبوط ولا لا؟ ايش بيساوي هذا؟ 7x. So therefore x is equal to what? 1 over 7. So probability of a 2 or a 4 is equal to what? 3 over 7. So what is probability of a 2 then?
1 out out of 2 multiplied by 3 over 7.
3 over 7 divided by 2 because they are equally likely, صح? So basically probability of 2 is 3 over 14, which is probability of 4. Okay, and the probability of I is equal to 1 over 7 for I in 1, 3, 5, 6. Okay, so this is basically, in my opinion, is the right way to solve this question, following exactly the same steps that we did in the previous question. Okay, but again, I'm just giving it to you. Maybe you, one of you might, be much smarter than me. If you really get convinced with the answer in the textbook, make sure you see me during office hours, during on Microsoft Teams, and let's discuss it together. Okay, and I'll be happy to change to the book's answer. If you can really convince me. Yes.
Doctor, what's the book's answer? What's the difference?
شوف ها. Go and check it out.
If we solve it with the book's answer, it's alright?
I'm telling you from now, we're not gonna give you this question in the exam. Okay? طيب. Okay. So now what I'm gonna do, well, first of all, let me do this.